let's get some word problems in here. So number 20 in the book on page 241. So like I said, with our typical word problems, if you guys want to pause it for 2 seconds, then way you can get a look at it. And some of these, hopefully those are becoming nice and easy and you're enjoying using your calculator. I know I do. Can you imagine if I made you use the formulas? Gosh, I'm such a nice person. Nah, it's okay. Let's read the problem, look in it, maybe fill out the what n equals, what I equals, and all that, and let's come back and check and see what we get. Okay, so with number 20, the Pieras are planning to go to Europe 3 years from now, and they've agreed to set aside $150 per month. So it looks like they're going to be doing, the payment's going to be a negative $150. They're going to be setting aside money monthly for a total of 3 years. So we're going to take the trip in 3 years. And they're saving money, so the present value is 0. They're trying to build up to a certain amount, and it's going to be at 8% compounded monthly. So the payments per year and the compounds per year are both 12. All we have to do is go to future value, ask it to solve it for us, and I get a future value dollar amount of, looks like $6,080.33. So there you go. Just by making $150 payments just every month in just 3 years, $6,000. Not too bad. Okay, let's look at number 24. So if you pause it, read number 24, see what you can form for yourselves, and we'll come right back. Okay, so it looks like this is a typical problem where you can see happen in the real world a whole lot. That this girl is making a down payment initially of $4,000 towards a new car. Okay, so then to pay off the balance of the rest of the car, she has secured a loan from her bank at a rate of 12% per year compounded monthly. So the interest rate is 12%. We're compounding monthly. Okay. Under the terms of her finance agreement, she's required to make payments of $420. So the payments are negative $420. And right away, and she's going to do it for 36 months. So obviously she's making these payments 12 times a year for 3 years, or they kind of did the math for us, and it should be 36 because she's making the payments monthly for 36 months. They kind of already did the math for us. Okay. Obviously, anytime you have a loan, what's always going to be the future value of a loan? Well, your goal is to pay it off, right? So your future value is going to be $0. All right, the present value is what we're looking to find here. So when we type all this in our calculator, we'll get a present value. And it looks like $12,645.15. Okay, now going back to the question just real quick, it asks us what is the cash price of the car. Okay, remember this present value is how much she's taking the loan out for. Because anytime you're doing this is all about a loan. It has nothing to do with the total value. Because when you go in there, she said that very first sentence that she has made a $4,000 down payment on the car. So really, the car price or the car's value is going to be the $12,645.15 plus the initial down payment that she made. So the real answer for the value is going to be then $16,645.15. And so that's the answer to the problem. So just a tiny little change from what we're used to doing, but that's just the only thing you have to do right there. Okay, so example number 6. And I really like example 26 in the book because it's what it's doing is explaining a little bit to you guys on, people that win the lottery, they give them 2 options. You can either take a lump sum or you can get equal payments. Okay, and this problem is kind of showing you a little bit about which really would be better for you. Okay, so let's read through this and kind of assign some values together. It says that the commission pays, so the State Lottery Commission pays the winner of $1 Million Lottery 20 installments of $50,000 every year. So this is in terms of the commission. The commission is paying out $50,000 every year. Okay, and it's going to be 20 equal installments. So it's like they're making payments 1 per year for a total of 20 years. So that's just really 20 up there. Okay, and it says we want to determine how much money the commission should have in the bank the beginning of all this payments, in order to guarantee that the payments are going to happen, so that they guarantee that they'll have $50,000 every year to pay this person. And we're going to assume that the balance on the deposit with the bank earns an interest rate of 8%. Okay, and obviously when we're doing this just one time a year, they're making one payment every year. The future value will be 0 because what this question is basically saying is, remember, pretend like I'm the commission, you guys just won the lottery, okay? And I'm the one that's taking the loan because I want to know how much money do I have to have in my account right now as being the commission to where I can write you guys checks, $50,000 every single year, just once a year, but every single year, okay? So what we want to know is what's the previous value, the present value of all of this. And what you're about to see is it's obviously not going to be just $50,000 times 20, because the whole fact of when I put money in the account right now, so if I set up a fund for you guys, you just won the lottery from me, when I put money in this account right now, I don't have to put in $50,000 times 20 years. I can put in fact, less than that, because that money, as it's sitting there, it's going to be earning interest until I have to pay out $50,000 more. And then that sum is going to be sitting there earning interest until I have to do it again. Okay, so let's find exactly what it is. Just go and go to present value, put your cursor there and hit alpha solve real quick. Okay, and so when we do this, what we're getting is a present value, let's see, of 22 million, well actually 2 million, sorry, gotta read this correctly. It would be nice if they put commas in for us. Okay, 2,229,159.70. I'm sorry, I was like, that's not looking right. That looks way too big. I accidentally put $50,000 in too many spots. Okay, let's double check with this. It's actually going to be just $490,000. Okay, and 907 and 37 cents. Okay, that looks way, way better. Okay, so if I, being the commissioner, if I just put money underneath my mattress, what I would have to do in order to make sure I had $50,000 to give you guys, I would have to stash away $1 million right now. Today, I have to stash $1 million. But because instead I'm going to be just investing the money, all I have to do is give you $50,000 right now. The rest of the other 364 days of the year, I can earn interest on that money. And so look how amazing this is. They only have to put in, they don't even have to put in half as much. Instead of putting away $1 million, they only have to put less than even $500,000 away. Because of the fact of they get to earn interest on their money. So when you win the lottery, because you all might win it someday, always, always take that lump sum. Because if you take the lump sum, you get to earn interest on the balance. If they pay you out, they're earning interest on the balance. Now, there is an exception to this. You can't just spend all the money at once. The thing is, if you win the lottery and you invest it, you're earning the money. I mean, obviously you can have fun with it and buy some things, go and splurge, but I'm just saying, don't just go on a spending frenzy, just pay, take that money and just buy things here and there, and that way you can have some saved and you can just live off the interest alone, It's really fun stuff like that. So, something to look at, really neat problem to even analyze, but let's go on to number 29 in the book. Okay, well, if we look at number 29 in the book, to finish up this little bit right here, what we're going to be doing is referring back to number 27. But the Johnsons deciding to secure a 15-year mortgage, and it looks like they're going to be making monthly payments. Okay, so N, if we go to N just real quick, and let's put that information in, it's going to be a 15-year mortgage, and they're making monthly payments. So the payments per year or the compounds per year are 12. Okay, so let's go through this problem. And at the very end, they're looking for the price range when the mortgage rate for this type of loan is 7%. So our interest is 7%. And right away, I can know the future value. Because the future value of a mortgage is hopefully 0. Hopefully you own your house when the balance is 0. Okay. So the Johnsons have accumulated a nest egg of $40,000. They intend to use as a down payment towards the purchase of a new house. Because their present gross income has placed them in a high tax bracket, they decided to invest a minimum of $2,400 a month into monthly payments. Okay, so the monthly payments are going to be $2,400. And then they go on to say that basically that that they could either make $2,400 payments or they could make $3,000 payments. Okay, now here's the question: what's the present value? Is the present value the $40,000 that they have as a down payment? Well, no. The present value, remember, this is of the loan. What you're finding out is the present value of what they're going to ask the bank for. So what they're going to ask the bank for is not $40,000. It's just they're going to take the price of the house, cut off $40,000, and then that's what they're asking the bank for. Okay, so this is all in reference to what's the loan amount. So we have two separate conditions here to consider. We want to know what the loan dollar amount is at $2,400 payments. Okay, and then we want to know the loan dollar amount when they can make the $3,000 payments. And this is going to give us the range that they're asking for, because they're asking for what's the range of prices they can look at for their houses. Okay, so we have to do this thing twice. One time where the payment's $2,400 and the other time for $3,000. Okay, so why don't you check and get both answers real quick. So when I type in the $2,400 for my payments, I get the $267,000 loan. When I type in the $3,000 for the payments, I get a $333,767 loan. Okay, so those are the two loans at each payment. It's going to be the $267,014.30, or it's going to be the $333,767.87. And then what the question though asks us is what range of prices can we actually technically go with. So this is what they're going to get the loan amount with, and then if we add on their initial down payment of $40,000, then we can consider, this will give us then the range of prices that they can go, okay, go to a realtor and say, let's find houses in this price range. Okay, so just add $40,000 onto those two, and then we'll get our answers. Okay, so the price range is basically anything from right about $300,000 up to $370,000 roughly. And that's what they can go to their realtor and say, hey, if I know that I for sure can only make a $40,000 down payment, but I can make these certain kind of house payments, then this is exactly what they're going to go to the realtor and say is, let's look for these price ranges. Not too bad for a house. Wouldn't y'all like to be able to buy a $300,000 home at this time? It'd be really nice.